Hello everyone and welcome to our video on the questions for the section on change in momentum and impulse momentum theorem. Alright, we're going to have a look at a question here. Alright, let's read it together. A toy car of mass 1 kilogram moves eastwards with a speed of 2 meters per second. It collides head-on with a toy train. The train has a mass of 2 kilograms and is moving at a speed of 1,5 meters per second westwards. The car rebounds or bounces back at 3,4 meters per second and the train rebounds at 1,2 meters per second. A. Calculate the change in momentum for each toy. Now, first things first, in step 1, we always analyze what we've been given. Over here, I've already done that for you. I've denoted M1 and M2, M1 being the mass of the car, 1 kilogram, and M2, mass 2, being the mass of the train, which is 2 kilograms. I have denoted VI and VF of the car. All right, notice that I'm taking east as positive. So initially, the car was moving eastward at 2 meters per second, rebounded or bounced back in the opposite direction westward. Hence, I've denoted its final velocity at negative 3,4 meters per second. Hope we can all see that. All right, the train was moving westward at 1.5 meters per second, but because east is positive, I'm denoting it as negative 1,5 meters per second. Then the train also rebounds in the easterly direction, and hence its final velocity is 1,2 meters per second. So the first question, calculate the change in momentum for each toy. We're going to begin by calculating the change in momentum of the car. We know the car's mass was 1 kilogram. So 1 kilogram, 1, VF, negative 3,4 meters per second minus 2 meters per second. All right, 1 times 3, negative 3,4 meters per second minus 2 gives us a final answer for the change in momentum of the car to be negative 5,4 kilograms per meters per second, according to the impulse momentum theorem. Now let's calculate the change in momentum of the train. We know that's equal to the exact same formula, m brackets VF minus VI. Taking m out as a common factor, you can multiply them in if you so choose to. All right? And we know the mass of the train was 2 kilograms. Multiplied. Its initial velocity was, or final velocity, beg your pardon, was 1,2 meters per second minus its initial velocity, which is negative 1,5 meters per second. All right? And that is equal to 5,4 kilograms per meters per second. All right? Positively. And right there, we have calculated the change in momentum for both the car and the train as well. All right? First question is answered. Let's have a look at the second question. Now we need to determine the impulse for each toy. All right? Now we know according to the impulse momentum theorem, we have in fact done that. All right? So we can just state that. So we can say the impulse, all right, for the car is negative 5.4 kilograms per meters per second, because this is equal to the impulse momentum theorem. And then the impulse of the train is equal to positive 5,4 kilograms per meters per second. All right, we've done that. Now C, the final question says, determine the duration of the collision of the magnitude of the force exerted by each toy is 8 newtons. So let's read that question again to get some more clarity. Determine the duration of the collision if the magnitude of the force exerted by each toy is 8 newtons. So each toy exerts the same force, all right? So let's just get a clean page here. All right, let's just get a clean page here quickly. So what are they asking us for? They're asking us for delta t. That's what they're asking us for. And we know that the F net from each toy equals to 8 newtons. So our impulse formula, all right, if we write our impulse formula down, we know that change in momentum is equal to F net, all right, times delta t. So we know that the change in momentum, or the impulse, over the net force, all right, is going to give us our change in time for the duration of the collision. All right, we worked out our change in momentum. Our change in momentum was 5,4 kilograms per newtons per second. All right, all over the net force, which was 8. All right, 5.4 divided by 8 gives us an answer of 0.675 seconds for the entire collision, to take place. All right, so we have answered C, and the answer is 0.675 seconds. All right, perfect. Let's have a look at another question. All right, this is a bullet question which comes up a lot. They like to ask the bullet questions, right? So a bullet of mass 20 grams strikes a target at 300 meters per second and exits at 200 meters per second. The tip of the bullet takes 0.0001 seconds to pass through the target. Determine A, the change of momentum of the bullet, the impulse of the bullet, and the magnitude of the force experienced by the bullet. So I'm going to leave this question to you to attempt on your own, and then I will do the solutions. So go ahead and attempt this question right now, and then come back to the video and see the solutions. Okay. Thank you everyone for going ahead and determining and attempting those questions. Thank you very much for that. And I'm going to go through the solutions now for each of those questions. Okay, so I hope this is how you approach the question, by firstly, on the right hand side of your page, just writing down what you have been given. The mass of the bullet, 20 grams, converting that into 0.02 kilograms. All right, VI is 300 meters per second. VF was 200 meters per second. Delta T was 0.0001 seconds. And we need to calculate the impulse and change in momentum. So firstly, the change in momentum. All right, we know the formula for that. Change in momentum is equal to mvf minus vi. All right, we know what the mass was equal to, 0.02 kilograms. All right, 200 minus 300. And we know that therefore the change in momentum is equal to negative 2 kilograms per meters per second. All right, that's all. Negative 2 kilograms per meters per second. Now B's question was, what is the impulse of the bullet? Well, according to the impulse momentum theorem, we know that impulse is equal to the change in momentum. So therefore, impulse is equal to negative 2 kilograms per meters per second. And there we go. Now C, all right, we need to calculate the net force. All right, so we know delta P is equal to F net multiplied by delta T. All right, we know F net will be equal to if we just want to calculate the force, which we need to calculate the force, would be equal to the change in momentum or impulse divided by delta t. Alright? We sub in our values there. We know that it was 2 all over 0, comma 0, 0, 0, 1. Alright? We take the positive value and we get the force, net force, to be equal to, that should be equal to 20,000 newtons is the net force. Alright, and there we go. And that is our solutions to the questions. Quite straightforward, quite easy if we just know our formulae. Alright, and it's very easy based on the impulse momentum theorem. Whatever our change in momentum theorem was will be equal to our impulse as well. Alright, thank you everyone for tuning into this video. Hope this wraps up the section of momentum and impulse.